Today, we're going to be taking a look at a particular concept in calculus. We're actually going to be solving differential equations. But in addition to solving the differential equation and finding the particular solution, we're going to take a look at how we can also find the domain. I've seen that there hasn't been a lot of emphasis on finding the domain of these particular solutions, or I should say these differential equations. So hopefully this will touch up on that and help you guys out with how to find a domain. With that being said, let's get into it. So the very first example I want to show you is where our differential equation contains an x value. So for example, we have dy over dx is equal to 1 plus y over x. And with a solution of f of negative 1 is equal to 1. So that is our solution. Since we have an x value, of course, here in our differential equation, we want to find the domain, or we can find the domain, I should say. How? Well, we have to take a look at, according to this x value, when, or I should say where, is dy over dx undefined? What x value will make this function dne, or again, as I mentioned, undefined? If you said x equals 0, you are correct, because we cannot divide by 0. Now, x equals 0 is not our domain. We either want to say that it will be less than 0, or it will be greater than 0. So which one would it be? How do we find that? How do you find if it's either less than or greater than? The key aspect is that we have to take a look at the sign of this x value here. So I said f of negative 1. So our x value is going to be less than 0, right? So because according to this solution here, since our x value is less than 0, again, if it's less than 0, our domain will be, as a result, x is less than 0. And that is your domain, just right there. So kind of a recap of this process here. We know that x is really less than 0 because, first of all, since we had an x value in our differential equation, we could discern that this function is undefined because x is equal to 0. But we want to find whether it was less than or greater than 0. And we could find that based on the sign of this x value here on the particular solution. Since this was negative, we said it was less than 0. But if this was positive, it would be greater than 0. So just keep that in mind. Okay, now I also then want to show you guys an example of where we have a y value. So we won't have an x value present. All right, guys. Now I want to show you an example where we do not have an x in our differential equation. We do not have, again, an x value. It's going to be y instead. So, of course, let me just write this out. You click the pen there. dy over dx is equal to 2 over root y with a solution of f of 0. Also, this is just the same as y of 0. Technically, it should be y of 0, but I'm just used to f. So f of 0 is equal to 9 is our solution here. Okay, so again, you don't see an x value here. So we can't really find the domain based on this equation. Instead, we need to find this solution first, because then we can find the x value that way, right? And then we can solve for the domain. So in this process, I'm going to show you how to solve the differential equation. That is our very first step before we can solve for the domain in this scenario again. So of course, we need to isolate both sides. So dy times the square root of y is equal to 2 times dx. And of course, we need to integrate. So that symbol, I write it like an S, but that symbol, integral sign of that. So integral of the square root of y, what I like to do first is it's the same as y to the 1/2. And then we want to find the integral of that, right? So we have to add 1 to the exponent. And whatever we have on top, we divide on the bottom. So let me write that there. Okay, y to the 1/2 plus 1. With mental math, that should be y to the 3/2 over, of course, 3 over 2, which you can simplify to 2y 3/2 over 3. So then you can also then, actually, let's not simplify this. Let's keep it as that. Because then I will show you guys how we can then solve for this y value after we kind of rewrite this exponent here. Okay, so let me move this part here. That is what we want. So that is our y at the moment. And then now we want to find the integral of 2 dx. Well, the integral of a constant will just always be 2 times an x value. Simple as that. And that makes sense, because if you find the derivative of 2x, that will just be equivalent to 2. Cool. So 2x is our integral on the right side here. So we can just take that, just take this snippet here. Perfect. And of course, delete all of this. Delete, pen, there we go. And then also we should not forget the plus c, which I sometimes do, because our c value, we want to find that in accordance with our solution. Okay, we can kind of simplify this here. So what I want to do here is multiply or get 3 on the other side. So if I multiply 3 and bring this here, it's just going to be 6x and still plus c. It's not going to be 3c, because again, our c value could be anything. And then we have 2, and then this is where I'm going to rewrite my y. So y to the 3/2 is the same as the square root of y cubed is equivalent to 6x plus c. So we can also then divide by 2 to simplify this here. And then it's just going to be equal to the square root of y cubed, and that is a y there. The square root of y cubed is equivalent to 3x plus c. Okay, well, if you want to find just y by itself, we have to take the cube root of this, which would translate to this part. So if I kind of move everything up here, I'll just write up here. So the cube root of this, trying to not run out of space here, again, that's cube root. And then whatever we do on the other side, we need to do on the right. So cube root of that. So then that would simplify down to the square root of y is equivalent to the cube root of 3x plus c. There we go. So what we can do now is we can, if we want to, we can actually plug in our particular solution here. So it would just be the square root of 9, which would be equivalent to 3 is equal to the cube root of c. The cube root of c, which would be equivalent to just we would take this whole thing cubed to the power of 3, really. And then this would translate to 3 to the power of 3. So 3 to the power of 3 would be 27. So our c value would be 27. Okay, let's kind of rewrite everything here. So we would have to have, it would be, and also let me just rewrite this part here. It would be the cube root of 3x plus 27. Okay, next step here, all we need to do is just square both sides, and this would get you y is equal to the cube root of 3x plus 27 is squared. Perfect. That is it. So in this particular scenario here, our domain here would be all real numbers. So let me also clear this up as well for you guys. again, as I mentioned, our solution here, or our domain here would be all real numbers. Well, why? Because it's this cube root. Our cube root can always be negative if we want it to, because in the end, the square here will make it positive. So the cube root of a negative number will still be a valid value. It will not make the function undefined. It will not make it DNE. So in this case, our domain, or we would not have any domain restrictions. But if it was instead, for example, let's say the opposite, so we switch those 2's and the 3's there, then it would have a domain restriction. In this case, 3x plus 27. So we don't want that to be less than 0, right? We don't want that to be a negative value. So if I write this here, 3x plus 27, when is that equal to 0? It will be equal to 0 at negative 9, right? Now, also, we don't want that to be less than negative 9. So, but how would we know if it was going to be, again, greater than or less than? Since this is 0, we have to kind of take a look at the domain here, because we have to kind of take a look at the equation, in other words, where it cannot be more than, of course, again, it cannot be a negative value. So in this case, our domain would be greater or equal to negative 9. So our domain in this case would have been x is greater than or equal to negative 9. If this was the scenario here. And that makes sense, because if it was even less than negative 9, this would be more negative, but we cannot have the square root of a negative value. But of course, our equation here was the cube root of 3x plus 27 squared. And again, in this case, as we mentioned, all domains work. It does not have any restrictions, because we can always have the negative of a cube root, or a cube root of a negative value. This is also our particular solutions, and our domain, again, no restrictions, so we can write really, if you want, all real numbers. All real numbers is our domain. So a quick recap of what we did here is that, again, I took a look at the differential equation. I saw that it was only a y value, right? Since there was only a y value, we had to find the particular solution first, the solution to this differential equation, which we did. And it was, again, this guy here, y is equal to the cube root of 3x plus 27 is squared. Then we were going to find when this function is not defined. What x value will make this function undefined? None of them worked, or really it did not have a domain restriction, which led us to say that the domain is ultimately all real numbers. Okay, so that concludes the video, guys. Thank you so much for watching. Hopefully this cleared up the concept of domains, and hopefully it will allow you guys to kind of see not only how to solve these equations, but also how to find their domain if there is ever a question where you are asked to find the domain of this these types of problems. So with that being said, guys, thank you so much for watching. I hope you found this video helpful, and as always, I will see you in a future video. Thank you so much.